Chapter 2 notes, graphing lines. In our last lesson, we learned how to graph lines using a table where we'd plug in the values into the equation and then graph the line. Today you're going to learn a shortcut to graphing linear equations, and it's using the equation. So follow along on the notes here. It says the graph of y equals mx plus b is a line. Okay, it's a linear graph. Equations that look like that will produce graphs that are a straight line like we learned about yesterday. Okay. The x and the y in the equation, that just stands for all the different points that we graph when we graph the line. The m and the b are the values that tell us where specifically we can graph the line using our shortcut method. Now, the letter m in the equation, the number that's always in front of x, that is called the slope. That tells us the steepness of the line, and it tells us whether or not the line goes up from left to right, like this one, or down from left to right, like this one. And it's pretty easy. When the slope is positive, the line's going to go up from left to right, and when the slope is negative, the line's going to go down from left to right. Slope is best thought of as a fraction, and the fraction is the change in y over the change in x. That triangle is, in algebra is called delta, and it means change. So it's the change in y over the change in x. The b in the equation, which is always the number that's by itself, doesn't have the x in front of it, that is called the y-intercept. And that is where the graph crosses the y-axis. Okay, the y-axis is the vertical axis if you look over to the right. So that value, whatever it is, that is where that line will cross that axis. We'll demonstrate kind of how this works in a second on how you would use that to graph. So the y-intercept is when the x is 0, okay, and you could say it's where the graph crosses the x-axis. I'm sorry, the y-axis. The x-intercept is when the y is 0. And this is where the graph crosses the x-axis. Okay? Now, as we learn how to graph these equations using this technique, we're most concerned with the y-axis, with the y-intercept. The x-intercept will be something that we look at a little bit later. So, on the right, you'll see it says sketch y equals 3 over 2x plus 1. So, the first thing you do is we always graph the b, or the y-intercept, first. And this is very simple. The y-intercept in this case is plus 1, so I just make a dot at positive 1. If it had been minus 5, then I would made a dot at negative 5. If it was 3, I would have made a dot at 3. So whatever that value is, you put a dot on the y-axis. Now, the number next to x is the slope, okay? And it's 3 over 2, which is positive. And when the slope is positive, that means the graph is going to go up from left to right. So it looks something like that, okay? We know that every time it has a positive slope, that that's the direction it'll go. And you'll notice that the slope is a fraction, 3 over 2. What that tells us is that we're going to go up 3 in the y direction, because remember the top of this fraction, if you look above, is the change in y. And since it's positive, I'm going to go up 3. So I actually start at my y-intercept and count up 3 units, okay? The bottom of the fraction is a 2, and that is the change in the x direction. Since it's positive, we're going to go to the right. So I went up 3, and then I count over 2. That is going to be the location of another point on my graph. And once I have the 2 points, I can connect them with a straight line drawn to the edge of the graph, and I put arrows on the end to show that they go on forever. So that 3 over 2, the slope, came into play because it showed us where to go from the y-intercept to get another point. The top number is always will be up or down based on if the slope is positive or negative. If it's positive, you count up. If it's negative, you count down. And the bottom number, 2, means we went 2 to the right. Let's try some examples below. Now, our first example on the left is y equals 2x minus 4. The first thing I would do when I'm looking at this equation is I would make the slope, or the number next to x, a fraction. Okay? Because I need to know, if you remember from above, I need to know how far to go in the y direction and how far to go in the x direction by looking at that fraction. Now, first thing on the graph is always the y-intercept. Since it's negative 4, I'm going to make a dot at negative 4. The slope is 2 over 1. The top number tells me to go in the y direction, positive 2. So I'm just going to make little x's there to show that. And then the number under the 2 is a positive 1, which means I go 1 to the right. That is another point on my line. I can connect those two with a straight line with arrows on each end. Moving on to the next example. The slope is already a fraction right there, so I don't have to do anything with that. And of course, I'll start with the y-intercept, which is a positive 3. Now, notice this time that the slope is negative. When the slope is negative, that means instead of counting up 2 for that top number, I'm going to count down 2 from the y-intercept. So 1, 2. And then the bottom of the fraction, or the denominator, is a 3, so I count 3 to the right. Connect my 2 points. And there is my line. So, on this one, just realize we went down 2 over 3 because the slope was negative. The next example, I would start at negative 2 with a dot because that's the y-intercept. The slope is 4/5, so I would count up 4 and then over 5. So the slope really just gives you a roadmap to another point on the graph besides the y-intercept. Again, this was up 4 over 5. Okay, and since that slope was positive, that's why I went up first. Now, this example, bottom left, y equals 4. Notice there's no x involved, okay? When there's no x involved, that means that there is no slope. There's nothing to count. All I have is the y-intercept, which is at 4. And when it's y equals 4, that is just a horizontal line through 4 on the y-axis. So this is a horizontal line, like the horizon, straight across, east to west. X equals negative 3, this is a vertical line, and this is the only, vertical lines are the only equation where it'll be x equals a number. Usually, if you look at all the other equations, they were always y equals. But if it's just x equals negative 3, they're basically telling you the x-intercept, and then our line goes straight up and down through there. We will talk more about those in the future. Our last example, y equals 3x. Notice the b is missing. There is no number added or subtracted over there. When that is the case, you just assume it's a 0. So my graph would start at the origin, 0, 0. And then my slope is a 3. Remember, we'd rather look at it as a fraction, so I put it over 1, which tells me to go up 3 over 1. So there's my second point. So if they leave off the y-intercept, you can just assume it is 0. Okay. One detail to note here, I'm going to slide this down a little bit. If you look at the first example, this one, a common mistake people make when they're graphing is that they start at -4 with the y-intercept, and they do that correctly. But then when they count the slope, some people mistakenly start counting the slope from the origin. Okay, go up 2 over 1. That is never what we do, okay, unless the y-intercept was 0. You always start counting the slope from the y-intercept, okay? So that's why we counted it from here and went up 2 over 1. Okay, so always count from the y-intercept. Good luck doing some graphing.